Welcome to the series of e-learning modules on project planning with PERT and CPM and drawing of project network. By the end of this session, you will be able to explain the importance of using PERT and CPM techniques for project management, explain the phases of any project and various activities that need to be done during these phases, construct network diagrams with single and time estimates of activities involved in a project. Let us start with an introduction. A project is an endeavor to create a unique product or service. It is specific, timely, usually multidisciplinary and always conflict-ridden. A project defines a combination of interrelated activities that must be executed in a certain order before the entire task can be completed. An activity in a project is usually viewed as a job requiring time and resources for its completion. Projects are a part of an overall program and are broken down into well-defined set of tasks, that is jobs, subtasks and further if desired, all of which must be completed within a specified time along with a minimum cost. Example of projects include construction of bridge, highway and power plant, repair and maintenance of an oil refinery or an airplane, design, development and marketing of new product, research and development work, etc. Such projects involve a large number of interrelated activities or tasks that must be completed in a specified time in a specified sequence or order and require resources such as personnel, money, materials, facilities and space. The main objective before starting any project is to schedule the required activities in an efficient manner so as to complete it on or before a specified time limit at a minimum cost of its completion. Hence, before starting any project, it is necessary to prepare a plan for scheduling and controlling the various activities or tasks involved in the given project. This will help in undertaking the project, possibly identifying bottlenecks and even discovering alternate work plan for the project. One of the most challenging jobs that any manager can take on is the management of a large-scale project that requires coordinating numerous activities throughout the organization. A myriad of details must be considered in planning how to coordinate all these activities, in developing a realistic schedule, and then in monitoring the progress of the project. The techniques of operations research used for planning, scheduling and controlling large and complex projects are often referred as to network analysis, network planning and scheduling techniques. All these techniques are based on the representation of the project as a network of activities. A network is a graphical plan consisting of a certain configuration of arrows and nodes for showing the logical sequence of various activities to be performed to achieve project objectives. Project management has evolved as a field with the development of two analytical techniques for planning, scheduling and controlling of projects. Fortunately, two closely related operations, research techniques, program evaluation and review technique and critical path method are available to assist the project manager in carrying out these responsibilities. These techniques make heavy use of networks to help, plan and display the coordination of all the activities. They also normally use a software package to deal with all the data needed to develop schedule information and then to monitor the progress of the project. The project evaluation and review technique and the critical path method were developed by two groups almost simultaneously. CPM was developed by E.I. du Pont-de-Nemours and Company as an application to construction projects and was later extended to a more advanced status by Mauchly Associates. PERT was developed by the US Navy by a consulting firm for scheduling the research and development activities for the Polaris missile program. PERT and CPM were independently developed in the late 1950s. Ever since, they have been among the most widely used OR techniques. However, they also hold a great deal in common, and the two techniques have gradually merged further over the years. In fact, today's software packages often include all the important options from both original versions. Project management software such as MS Project now is widely available for these purposes. Consequently, practitioners now commonly use the two names interchangeably or combine them into the single acronym PERT or CPM, as we often will do. We will make the distinction between them only when we are describing an option that was unique to one of the original version. Although PERT and CPM were developed independently, they are similar in principle. Today, PERT and CPM actually comprise one technique, and the differences, if any, are only historical. Consequently, both techniques are referred to as project scheduling techniques and play an important role. Coming to the significance and uses of PERT or CPM. Let us understand the significance of using PERT or CPM. A network diagram helps to translate highly complex project into a set of simple and logically arranged activities, and therefore helps in the clarity of thoughts and actions, helps in clear and unambiguous communication developing from top to bottom and vice versa among the people responsible for executing the project. Detailed analysis of a network helps project in charge to peep into the future, because difficulties and problems that can be reasonably expected to crop up during the course of execution can be foreseen well ahead of its actual execution. Delays and holdups during course of execution are minimized. Corrective action can also be taken well in time. Isolates activities that control the project completion and therefore results in expeditious completion of the project. Helps in the division of responsibilities and therefore enhance effective coordination among different departments or agencies involved. Helps in timely allocation of resources to various activities in order to achieve optimal utilization of resources. PERT and CPM have been used for a variety of projects, including the following types: construction of a new plant, research and development of a new product, NASA spare exploration projects, movie productions, building a ship, government sponsored projects for developing a new weapon system, relocation of a major facility, maintenance of a nuclear reactor, installation of a management information system, conducting an advertising campaign. Coming to the phases of project management. In general, project management by PERT CPM consists of three basic phases, that is planning, scheduling and controlling. Coming to the project planning phase. In order to visualize the sequencing or precedence requirement of the activities in a project, it is helpful to draw a network diagram. The following tips are adopted for the project planning phase, that is to identify the various activities or task or work element to be performed in the project, that is develop a work breakdown structure WBS, determine the requirement of resources such as men, materials, machines, money, etc. for carrying out activities listed above, determining the time estimates for these activities, assign responsibility for each work package. The work packages corresponds to the smallest work efforts defined in a project and forms the set of elemental tasks that are basis for planning, scheduling and controlling the project. Allocate resources to work packages, develop work performance criteria, establish control channels for project personnel. Coming to the project scheduling phase. Once all work packages, that is tasks, have been identified and given unique names or identifiers, Scheduling the project, that is when each of the activities are required to be performed, is taken up. It prepares an analysis by estimate of the likelihood of the project to be completed on or before the specified time. The various steps involved during this phase are listed below. Identify all the people who will be responsible for each task. Estimates the expected duration of each activity, taking into consideration the resources required for their execution in the most economic manner. Specify the interrelationship, that is precedence relationship among various activities. Develop a network diagram showing sequential interrelationship between various activities. For this, tips such as what is required to be done, why it must be done, can it be dispensed with, how to carry out the job, what must precede it, what has to follow, what can be done concurrently may be followed. Based on these time estimates, calculate the total duration of the project, identify the critical path, calculate floats, carry out resources smoothing or leveling, exercise for critical or scarce resources, taking into account the resource constraints if any. Coming to the project control phase. Project control refers to the evaluation of the actual progress or status against the plan. If significant differences are observed, then the scheduling and resource allocation decisions are changed in order to update and revise the uncompleted part of the project. In other words, remedial, that is modifying planning, or reallocation of resources, that is cost minimization measures, are adopted in such cases. The relationship among the phases of project management is shown in the diagram. It indicates how the actual task performance data is used to track deviations from the original plan and schedule. These adjustments are helpful to aggregate work packages into subsystems and track the progress of these subsystems as part of the reporting and review procedures. In this way, it is less likely that a project manager will lose sight of the forest because of too many trees. Now coming to PERT or CPM components. Let us now discuss about PERT or CPM network components. Events. Events in the network diagram represent the project milestones such as the start or end, the completion such as the start or the completion of an activity or task or activities, and occur at a particular instant of time at which some specific part of the project has been or is to be achieved. Events are commonly represented by circles or nodes in the network diagram. The events can be further classified into merge events and burst events. Coming to merge events. An event which represents the joint completion of more than one activity is known as a merge event as shown in the diagram. Burst event. An event that represents the initiation or beginning of more than one activity is known as burst event as shown in the diagram. Events in the network diagram are identified by numbers. Each event should be identified by a number lighter than one allotted to its immediately preceding event to indicate progress of the work. The numbering of events in the network diagram must start from the left, that is start of the project, to the right, that is completion of the project, and top to bottom. Care should be taken that there is no duplication in the numbering. Coming to the activities. Activities in the network diagram represent project operation or tasks to be conducted. As such, each activity except dummy requires resources and takes a certain amount of time for completion. An arrow is commonly used to represent an activity with its head indicating the direction of progress in the project. Activities are identified by the numbers of their starting, tail or initial event and ending, that is head or terminal event. For example, consider an arrow ij between two events. The tail event I represents the start of the activity and the head event j represents the completion of the activity. The activities can be further classified into the following three categories, that is predecessor activity, an activity which must be completed before one or more other activities start is known as predecessor activity. Next is successor activity. An activity which starts immediately after one or more of other activities are completed is known as successor activity. Dummy activity. An activity which does not consume either any resource or time is known as dummy activity. A dummy activity in the network is added only to establish the given precedence relationship among the activities of the project. It is needed when two or more parallel activities in a project have the same head and tail events, or two or more activities have some but not all of their immediate predecessor activities in common. A dummy activity is depicted by a dotted line in the network diagram as shown in the figure. Network models use the following two types of precedence network to show precedence requirements of the activities in the project: arrow on node network and activity on arrow network. Coming to activity on node network. In this type of precedence network, each node or circle represents a specific task while the arcs represent the ordering between tasks. AON network diagrams place the activities within the nodes and the arrows are used to indicate sequencing requirements. Generally, these diagrams have no particular starting and ending nodes for the whole project. The lack of dummy activities in these diagrams always make them easier to draw and to interpret. Next, coming to activity on arrow network. In this type of precedence network, at each end of the activity, arrow is a node or circle. These nodes represent points in time or instance when an activity is starting or ending. The arrow itself represents the passage of time required for that activity to be performed. This diagram then works its way from left to right, ending with a single ending node where all activities with no followers come together. Three important advantages of using AOA are as follows. Many computer programs are based on AOA networks. AOA diagrams can be superimposed on a time scale with the arrow drawn the correct length to indicate the time requirement. AOA diagrams give a better sense of the flow of time throughout a project. The following diagrams illustrates the representation of the activities using a AOA network diagram and AON network diagram. The first example shows the representation of activity A. The next figure shows the representation of the activity B following activity A. B and C must follow A, C must follow A and B, and C must follow A, and D must follow A and B. Now next, coming to the rules for AOA network construction. Following are some of the rules that have to be followed while constructing a network. In network diagram, arrows and circles represent activities and events respectively. The length of an arrow is of no significance. Each activity should be represented only by one arrow and must start and end in a circle called event. The tail of an activity represents the start and head the completion of work. The event number 1 denotes the start of the project and is called initial event. All activities emerging or taking off from event 1 should not be preceded by any other activity or activities. An event carrying the highest number denotes the completion event. A network should have only one initial event and only one terminal event. The general rule for numbering the event is that the head event should always be numbered larger than the number at its tail. That is, event should be numbered such that for each activity ij, where I is less than j. An activity must be uniquely identified by its starting and completion event, which implies that an event number should not get repeated or duplicated. Two activities should not be identified by the same completion event. Activities must be represented either by their symbols or by corresponding ordered pair of starting completion events. The logical sequence or interrelationship between activities must follow these rules. An event cannot occur until all its incoming activities have been completed. An activity cannot start unless all the preceding activities on which it depends has been completed. Though a dummy activity does not consume either any resource or time, even then it has to follow the rules of A and B. Now coming to errors and dummies in network are shown below. Looping and dangling. Looping or cycling and dangling are considered as faults in a network. Therefore, these must be avoided. A case of endless loop in a network diagram, which is also known as looping, is shown in the diagram where activities A, B and C form a cycle. Due to precedence relationships, it appears that every activity in looping is a predecessor of itself. In this case, it is difficult to number 3 events associated with activity A, B and C so as to satisfy the rule of constructing the network. A case of disconnect activity before the completion of all activities, which is also known as dangling, is shown in the diagram. In this case, activity C does not give any result as per the rules of the network. The dangling may be avoided by adopting rule 5 of the constructing network. Now coming to dummy or redundant activity. The following are the two cases in which the use of dummy activity may help in drawing the network correctly as per the various rules. When two or more parallel activities in a project have the same head and tail events, which are two events connected with more than one arrow. In the figure, activities B and C have a common predecessor, that is activity A. At the same time, they have activity D as a common successor. To arrive at correct network, a dummy activity for the ending event B may show that D may not start before B and C is completed. This is shown in the figure. When two chains of activities have a common event, yet are wholly or partly independent of each as shown in the figure. A dummy which is used in such a case to establish proper logic relationships is also known as dummy activity. In the figure, if head event of C and E do not depend on the completion of activities A and B, then the network can be redrawn as shown in the figure. Otherwise, the pattern of the figure must be adhered to. Coming to the summary. Here's a summary of our learning in this session, where we have understood the importance of using PERT and CPM techniques for project management, the phases of any project and various activities that need to be done during these phases, and also to construct a network diagrams with single and time estimates of activities involved in a project. Thank you.